Okay, so let's start with number 1. Number 1 says a weight is attached to the end of a spring. As it bounces, its distance from the floor varies sinusoidally with time. When the stopwatch reads 0.3 seconds, the weight is at the high point of 50 centimeters. And then the next low point occurs at 1.8 seconds. So we really want to kind of rely on these as our anchors here. So just going to arbitrarily choose my first x value to be 0.3. I know 0.3, I'm going to hit the maximum value of 50. And then at 1.8, I'll hit a low point, 30 centimeters. So I know my graph is going to look something, at least initially, like this. Even though I don't know the rest of my graph, I know that the horizontal distance from my max to my min is always going to be half of my period. Okay. So I don't know exactly what's happening at 0, but I do know that this is going to help me find half my period. Are we okay with that? Okay, so we do 1.8 minus 0.3, we get 1.5. And since 1.5 is half the period, if I double it, 1.5 plus 1.5 must be equal to 3. Okay. From there, I can work towards getting to my B value. Cross multiply. Okay, that's my B value. I can find my D value by finding the average between my high and low. D is 20, so A, my amplitude, is the distance from my midline to the peak. I'm sorry, this is 40. To 50, that's amplitude of 10. Okay, so I'm gonna, I think cosine is gonna be the better fit because I would like to start at the peak. I just need to shift it starting here. So I'm gonna create an equation here. So this equation that I have right now, we don't see. Okay, the reason why is because this is centered starting at 50. It looks more like that. Okay, but I want this graph to shift so that it'll land in the graph that I want it to land. So that means I want to shift it 0.3, which will allow that 0.50 to move to 0.350. Okay, are we good with that shift there? Okay, good. That's our equation. Okay. Number 2. Okay, see you, Diana. Roller coaster. The nice thing is they tell us that it's starting at the minimum. The highs and lows are separated by 50 meters horizontally and 30 meters vertically. So that means 50 meters later, we should be at the peak. It says 30 meters vertically. So if I rise 30 meters from 3, I'm at 33. So I know my graph is going to start off like this. Once I know that horizontal distance from the peak to the valley or valley to the peak, I know I've achieved half the period. So period must be double that. Okay, we get to our D value by finding the average between these two numbers. So 3 plus 33 is 36. 36 divided by 2 is 18. I see it. A value is the distance from D to the peak. Period is 2 pi over b. Okay. I think I have everything that I need. Now this starts at the minimum, so this, there's no phase shift, but what do we have to be aware of if we want this to be a cosine? Good, reflected, so there our A is going to be negative.
Do you want me to reflect it on this one because you want it to be a cosine, or if you want to do a sine one, you also do it?
Well, if you want it to be sine, then you would have to figure out where that midline is. If you want to figure out that midline, then you would have to find your interval. So, okay, so if you want to do the interval would be 1/4 times 100. So yeah, you could have it being sine, but then shift it to the right 25. So I'll write that equation as well if you want to do that. So the midline is 25 units over. I can do minus 25. This will work as well. Either one works. Vertical support is needed at 10 meters. How tall should the support be? I can plug 10 into either equation. Okay, any questions with 2? Okay, here's number 3. A wave passes by an offshore piling. The height of the water is modeled by the function. H of t is the height in feet above the mean sea level at time t seconds. Find the period of the wave. We have the b value given to us, so we can jump directly into finding our period. Two pi over b. Dividing by a fraction is the same thing as multiplying by the reciprocal. Okay. Finding the wave height, so we just have to measure the distance from the valley to the peak. So we know our amplitude is 3. So that means there's a difference of 6, right? From the peak to valley, it's going to vertical distance is 6. Okay. Number 4. Okay, so far? Okay, number 4, tuning fork. Yes. Radians. Yeah, radians. Find the period of the vibration. Period is just 2 pi over b. So 1/440th of a second. Okay, number 5. Particular beach. We find that at 2 p.m., the depth of water at the end of the pier is 1.5 meters. At 7:30, depth of the water is 1.1 meter. Assume that the depth varies sinusoidally with time. Find an equation. Okay, since 12 a.m. So we're thinking of 12 a.m. as time 0. So we know the max occurs at 2 p.m., which is really 14 hours after midnight. So think of it in terms of military time. Because 12 p.m. is 12, 1 p.m. is 13, so 2 p.m. is 14. Your min is going to occur at 7:30, so that's 5.5 hours later. Okay, so we know that this graph is going to go from 14 hours to 19.5. In that time period, it'll go from the maximum, down to the minimum. Okay. We know that distance is half the period. We can find our d value by finding the average between these two. And our a value is that difference between max and the d value. This is the handout I have. Yeah. Got a key there too if you want to pick one up. So if 5.5 is half the period, we know period must be double that, 11. Everything that we need is available. We just have to keep in mind that if we want our cosine function to initially start at 0, we will have to shift it over 14 units so that it can hit that max. Sorry, 1.3. So this equation is an imaginary graph that I don't have yet. But it's basically starting at the peak at 0. But now I have to figure out how far I have to move so that it'll line up nicely with this graph. So what's my shift, phase shift? Minus 14. Okay, predict the depth of the water at 5 p.m. the following day. So this is going to be, a full day after midnight. And then we got to add on another 17 hours. So 24 hours is going to pass. And then 5 p.m. is another 17 hours from midnight. Mm-hmm. No, it's going to be one full problem, and it's just with multiple parts. But here we're kind of just seeing a lot of different scenarios. Yeah.
I do that 41. Or I do that 24.
Oh, how'd I get to 41? So this is 5 p.m. on the following day. So to get from August 2nd to August 3rd, there's going to be 24 hours, right?
Oh.
And then from 12 a.m. on the 3rd, there's another 17 hours that pass. So it's basically a day and a half. So 41 hours. Okay, Mark Twain on the deck of a river steamboat. Okay, good. So it starts off highest point, 4 seconds, and then completes a revolution every 10 seconds. Okay. Okay, bye. See you. Mm-hmm.
Can you help me out with this one? Number 2. So it says here that minimum first point. So at the equation, so that this would be 3. This is where it would start, and it would go like this. And so it says the low point is 3 meters around, just that, and then the track is separated by 50 meters horizontally and 30 meters vertically. So this would be 33 and 50 meters. So this to this is 50, or
this to this is 50. That's 50. So that distance is 50.
got it. So 1, 2. So the period would be 100. So the equation for this would be.
See ya. All right. See ya.
So 15 sine. It would be sine or cosine?
You can do it either one. I did it as cosine because I'm thinking of it as starting at the minimum. But you could also go through your interval formula and find that midline, and you can start the sine over here at the midline.
The cosine would be easier. So cosine.
But it's a negative because it's starting at the minimum, so it's negative 15. Because usually cosine starts at the peak.
Yeah, right? So negative cosine of, here it is, so pi over 50. And then theta. There's no, what do you call it, PS?
No phase shift.
Phase shift. And plus 3.
Plus 18.
No.
D value is
18.
halfway between.
Yep.
Okay.
Plus 8. Got it. So that is correct. Cool. And the vertical support is needed at 10 meters. X equals 10 meters.
Just plug 10 in for theta. And use your calculator.
Okay. So this would be like theta, or pi over 5 plus 18. cosine. And negative 15. And you just plug this into the calculator.
Yeah. Double check with the key.
Kinesis. So it would be negative 15 cosine of, let's see, pi over 5 plus 18. And 5.86. All right. And this is a different problem. Okay. Can you give an example of what something the test would look like?
I think these all kind of hit on the things that you want to be able to see. It's good to write cosine function in terms of sine as well, so that if I ask you for cosine and sine.
So the test, that would be one of these, and it'll ask like cosine function, sine function, what this will be at this meters.
Period, A, D, yeah, all that.
Okay, that's it.
It's just one problem, and it's just parts A through however much for that.
Is there going to be domain and range? All right, cool. Thank you.
Okay, so here's number 6 here. 4 seconds, it's at the highest point. But the diameter is 18 feet, which means that it's going to go all the way down to -2, right? Because it's going to, if the diameter is 18 feet, it's got to stretch down to -2. So actually, the paddle is going to reach beneath the water surface.
Are any of these word problems going to be tangent or?
No, all sine and cosine. And we know it's going to take 10 seconds for it to complete its cycle, so we know 9 is the halfway point. Okay, does that make sense? 10 seconds, max 16, minimum -2.
So how do you know that it's going underwater?
Because the diameter is 18 feet, so if it's only hitting a max of 16, it's going to have to dig below the water to create that 18 meters of distance.
Okay.
And also the paddle will be underneath the water so that it can actually create the current. I can actually move the boat. Okay, so this is good because now we know what our period is. We can figure out our B value. We can draw and figure out our D value. We can figure out our A value.
Are we going to be going over this class or just a help session?
Maybe 5 minutes for you to just review, but I want to give most of the class period for you to take the quiz.
So how many problems are there?
Just one problem with
So will there be like wording, like will the wording be like concise? Like, because this problem 6 was a little confusing.
Which part was confusing?
Like how the wheel is 18 feet,
Mhm,
but
mhm.
the highest is like 16.
Yeah, I think it'll probably be more clear than that. But this makes sense though, right? That you
Yeah,
can kind of
makes sense.
visualize it. Okay. Okay, so I think cosine is the easier one because I can imagine the peak being at 0, and I just have to shift it over 4 seconds. But I think after we write our sine function, or cosine function, let's also write the sine functions to kind of practice kind of going back and forth between them. So are you good with the cosine function? Okay. Now, what if you're forced to write the sine function? That means we need a midline. Either you do the midline here or the midline here. But to find the midline, it helps if we find the interval. So 10 over 4 is 2.5. So if I do 2.5 from 4, I get 6.5. And then from 9, I get 11.5. So if I want to do it from 6.5, I can. I just have to make sure that I got to reflect it because the graph is going down. Another option is I can shift it all the way over here to the second midline and just let it be positive because it's rising from what I expect from a sine graph. So that's 11.5. Okay. 17, plug 17 seconds into any of these equations. We should all get the same thing. Okay, any questions? I'm sorry? Yeah, that just means it's either sine or cosine. It's always going to kind of oscillate back and forth between the midline. That's just all it means.